lines. Okay, so today we are looking at proving that lines are parallel. So last week, boys, please. Last week, we talked about some angle laws that some of them are true in parallel lines. I'm going to go through those. So what you can do on your sheet there, where it says recall our angle laws, when I go through this, you can write it down as well. So the first thing is we have corresponding. Okay. And corresponding angles, that's just shorthand for angles, are equal. Okay, this is all for parallel lines. So on parallel lines. So when you're spelling parallel, you need to remember it has one R and two L's. Well, it actually has three L's, but it's not double R, single L, it's one R, double L, just FYI. So when we have parallel lines like this, and we have a line going through, the corresponding angles make an F shape. Okay, so it's going to be here and here are corresponding, and you can sort of see there's an F shape created. This time the F has been inverted onto its side, but you can remember corresponding or corresponding to remember that it's the F shape made when you have parallel lines like that. So it's a big F shape. Okay, the other ones that we have, alternate angles, alternate, and they're also equal on parallel lines. And when we have alternate angles, okay, again, if I have my parallel lines like this, the alternate ones make a sort of Z shape, okay? So if I have one here, the alternate one is back here, and you can sort of see this makes a Z of sorts. Okay, there are multiple different alternate angles there, but just if you're trying to compare two different angles, we can remember that they're alternate by that Z shape. So you can remember it as alternate angles. Alternate angles are equal. And then finally, we have co-interior. Okay, and they are supplementary, which means they add up to 180. Oop, supplementary on parallel lines. Okay, and they make a C shape. So if you have a dot here, the co-interior one is a cross. Now I've written it as a cross, not a dot, because they're not equal angles. They are supplementary angles. So it's the two angles on the inside. Okay, remember co-interior because they are both interior, both inside the parallel lines. So this makes a C sound. Okay, so that's what we can do. Or these are our three parallel line laws that we can use to work with angles here. And we can use this to prove whether or not a pair of lines are parallel by the angles that we're given. So I'm just going to do one example here. It says co-interior angles are supplementary on parallel lines. Okay, so the last one here, determine whether each pair are parallel. So we're not told. You can see there are no arrows indicated on the diagram. We can't assume they're parallel. We need to prove that they're parallel. So here we have two equal angles. And we've got to think, well, what shape is made here? We can see it's kind of like an F shape. So these two angles are corresponding. And because they are equal, then those lines must be parallel. Okay, so we're kind of working in reverse. Rather than saying on parallel lines, those angles need to be equal, it's because they're equal, the lines must be parallel. Okay, you can see the logic is kind of reversed from the other way that we've done it last week. Okay, so for our answer, we'd say yes, as, and our reason, okay, to prove that their thing is as the corresponding angles are equal. Okay, so that's just our reason. Now, sometimes you could just write that in brackets. Okay, you could just say yes, brackets, corresponding angles are equal. That is fine too. No, you don't. Well, in this case, it is parallel because the corresponding angles are equal. Okay. In this example here, B, we have two angles here, and we can see that they make a Z shape. Okay, so they're alternate angles. However, they're not equal. So I would say no. Okay, and our reason is the alternate angles are not equal. Okay, and that's how we would sort of show our reasoning to determine whether or not parallel lines are, or whether or not, sorry, two lines are parallel or not.